And that's called now game tree search. And I'll give you a little bit of an idea of it. It's becoming a bit technical, but in principle, I want just to point out what you need for it. What you need for it is to have an idea what the utility of the user is. Utility means what the user wants, what the user gets out of this interaction, and what the goals of the user are. In tic-tac-toe, it's very simple. In tic-tac-toe, the user tries to win, and the AI tries to win. So it's straightforward. In an interactive drama, it's not quite clear. What is the user after? Well, probably the user might be after an interesting experience, after a satisfying experience, but even that might not be true. Because sometimes the user just tries to break the system. We've just had a discussion before about that. And so what is the utility of the user is a very hard problem, but we need the utility of the user in order to make a prediction of how the user will behave. So if we have the utility of the user, so if we know that if the user ends up here, the user gets a utility of 9, the AI gets a utility of 8, so the AI has also its own utility, like for example trying to create fast experiences or well-timed experiences or experiences with a clear narrative arc, and all these kind of things that the AI from the point of view of the computer has as utility and the user. And these two things don't have necessarily to go hand in hand. Sometimes the AI might have one interest and the user has a different interest, and we just need to look at predicting what the user wants and what the user is going to do, and predicting what the AI is going to do as well. So in this case, I'm just saying that the first number that I have in, say, here in a game that has only 2 turns, is the first number is the utility of the AI, and the second number is the utility of the user. And at that point, I have now these pairs of numbers at the end of the game. And now the question is, which will the user choose? Well, if the user has a choice at this point, the user will try, of course, always to maximize his utility. That means he will try to get the best out of the game in terms of what he wants from the game. And therefore, the user will definitely perform this action, because this gives him a 9 versus a 2 or a 5, so that's certainly better. So you can see here a problem already, namely that we are trying to express utilities as numbers. So that's in itself a whole difficulty. And in this case, the user will choose that move because he will try to get 10 utility points rather than getting 8 or 1 for the other possibilities. And in this case, he will try to get 8. So what we can now say is that all these nodes will actually have this outcome. If the user has a choice here, he will go down that path, and that means this node has an outcome 8,9. So we can propagate the outcomes of the game, of the interaction, up the tree. So I can now say these are the outcomes, and if I, as an AI, now have to choose between these 3 outcomes, well, I will certainly choose this one, because that gives me 8 points versus 2 or 2 points in the other possibilities, so therefore this is the better outcome. So therefore, for the AI, the best move is going to be A1, this kind of action that the AI can perform. And so each player tries, therefore, to maximize the payoff. So as soon as we have this idea of a payoff or a utility, at that point, we can certainly predict what each player is going to do if we can search the tree. Again, the problem is that we might not be able to search the whole tree because the tree is too big. Even for a game such as chess, it's not possible to do, and won't be possible for a very long time. And therefore, we need to have, again, heuristics that tell us how good is some intermediate state without having to actually search to the end state. How good is an intermediate state based just looking at the state for the AI and for the user who's interacting with the AI. So when we now look back at the components of the search, we still have the search space and the search operators and the heuristic as before. Now we need, in addition, a utility function. So a payoff function for each player. That means for the AI, what is the AI trying to achieve, and what is the player trying to achieve, and how do the states the nodes of the tree relate to the level of achievement. So in interactive storytelling, therefore, the search space could be story states again. We have two players, it's the AI and the human player. And we have search operators, which are the actions of the AI that are story events, actions of AI characters, and so on. And the actions of human player characters. That could be one way to frame it, but it's not the only way by far. It's just already giving a certain bias to the type of interactive drama that you're presenting. In this case, it's that the human is actually playing actions for an avatar, for a character that he stands for, and the actions of the AI are actually, in this case, story events and actions of AI characters. It's central AI. And the utility function for the player, well, here we get into the difficulties like enjoyment, and I put a question mark there because it's not clear what it means, and it's not even clear that the player wants enjoyment. And heuristic, if we want a heuristic that tells us what to try out first, is it interesting as a story? Should an AI try to make the story more interesting? And if it tries to do that, how can we describe it? What is the way to look at a story and decide whether it's interesting or not in a fairly mechanical fashion? So, kind of in conclusion, so AI is search. So that's the main point I really want to get across, and any AI method is going to be a search method. And you might say, oh, is that now disappointing? I don't know, did I now shatter any illusions about what we can do with AI? Well, you have to be careful, because there are people, first of all, that say that the brain isn't doing anything else but doing an efficient form of search. So therefore, in principle, when a chess player plays, he is looking at the board and trying out in his mind, consciously or subconsciously, it doesn't matter, all kinds of moves. If we are interacting with other people, we are maybe subconsciously also looking at all possible actions that we can take, all things that we can say, and then pick the ones that look best to our brain. So therefore, interestingly, the Deep Blue, which was the chess computer that played against Kasparov and won against Kasparov, actually after the games, Kasparov was asked whether he had any opinion about Deep Blue as a computer, and he said, well, I thought that Deep Blue has a character, that there is a certain human characteristic to the play that the Deep Blue computer displayed, and therefore we really maybe should not discount search as something, oh, that's just something mechanical and will never get us to creating intelligence, whatever your definition of intelligence is, or at least creating human-like behavior. But it could, but we have also to see, though, that even in Deep Blue, there was a lot of human input, and that was in terms of heuristics. So Deep Blue was built on top of heuristics that had been given to Deep Blue by grandmasters and by human developers. So this kind of human character that Kasparov felt when he was playing against Deep Blue might be due to this human input and not to the actual search mechanism. So you cannot see the search mechanism separate from the heuristic. And that is my other claim, and I'm happy to discuss this afterwards, and it might be controversial. My claim is that every storytelling AI defines, sometimes not explicitly but implicitly, it defines a search space. It's what are the things that we are looking at as potential story elements. It defines the search operators. What are the things that change a story or modify or tweak a story while creating a story. It defines a utility function, implicitly implying what the developers of the storytelling I think is interesting or useful for the user who's interacting with it, and they define heuristics. Maybe what are the paths in the search space, what are the space, the areas in the search space that are more worthwhile to explore than other areas, what stories are more worthwhile to explore than other types of stories. So they all define that. Even if they don't call themselves explicitly being a search method, and even if they don't tell you that in the research papers, implicitly you can frame all of the research that is happening in interactive storytelling in these terms. And therefore, however, what we need for this storytelling AI is we need formal definitions of all of these above. And sometimes it will help us to make these explicit. We shouldn't just keep them implicit in the system, because if you keep them implicit, we are making assumptions that might not hold up, that might not actually be true, about what the user likes and about what what kind of stories are preferable to other kind of stories. So, and heuristics in general need to be provided by humans. There is research in terms of trying to create automatic heuristics, but at that point I would say we still need very badly the human experts who are providing us these heuristics and ideas about the utility functions. So making these AI requirements now explicit helps certainly understand where the big gaps in the knowledge are and where the difficulties and problems of AI are in this area of interactive narrative. So far, I would say that there are absolutely no clear ideas and no thorough research on heuristics for storytelling. So when you look through the literature in interactive storytelling, you won't find much on this. And when you look even through the literature on narrative theory, as David can tell you because he has been reading about this for the past year, you won't find much information about what makes a good story and what makes a good narrative. You'll get definitely nothing that is constructive in any way. You get maybe some fuzzy, let me be controversial, it's fuzzy ideas, but you won't get something that you can then take and implement into a computer algorithm. We need, therefore, storytelling experts to help. So this is maybe also the challenge for not just the engineering side, but also for the ones who are coming from the writing side, from the humanities, to really give us a bit more of something to handle, something with more meat, than something tangible to tell us what makes a good story. Maybe we need psychologists to tell us what makes a good story in terms of evaluating reactions of humans to stories. But we need someone to tell us, because as engineers, like me, I'm not able to do that. I just don't have the expertise. I know how computers work, I don't know how humans work. And so therefore this is now pretty much over to you, and I'm now very happy and willing to take any kind of attacks on my views, which deliberately was controversial.
Well, I think there's lots of knowledge out there how to make a good story, and but the problem is it's not explicit formal definitions.
Yeah.
What would you actually mean?
But how would you then define knowledge? For me, knowledge is something that is explicit. Otherwise, it's kind of gut feeling.
I want to go on. I think because I've worked in this field also and found that if you now ask authors, now tell me, and also experts, they won't be able to give you this explicit formal definition. So you have to actually work together with them. So I know of no system so far which has these kind of heuristics or perfect utility function. So actually it's a challenge to work together to first teach also authors what you need, and then in a loop go on.
Yeah, I couldn't agree more with that. We definitely need the help of clients.
Okay, 2 separate points. Your initial argument that AI is search.
Yep.
My friends on the internet are arguing that pattern recognition is not search. If you teach a neural network to identify the difference between cats and dogs, that's not the active learning. Yeah, I agree with the debatable, but there is a. Well, would you like to comment on that?
Yeah, I can. I'm happy to comment on it. My view is that you're searching the space of neural networks. You're searching. Each neural network is now a node in your tree, and you're searching. With each example, you're actually modifying your neural network.
So that would be a neural network with a genetic algorithm wrapper.
Yeah, or a search wrapper.
Yeah.
Because in the end, any modification that you make on the neural network is actually a search operator.
Okay.
And,
Yeah. My other question is, I had a stab at this problem naively some years ago. The approach I found to it was to take the classic hero's journey monomyth archetypal story, and I used Christopher Folger's model from the book The Writer's Journey. I've broken out a series of phases, to find each phase as an interaction between two archetypal characters, which are there's a mask that you play by multiple roles, and generating stories using that model. So you pick genre-appropriate characters who can wear that mask, and you have a series of phases where these characters interact in some way whilst fulfilling those archetypal roles.
Mm-hmm.
And then I had a simple genetic style mutation algorithm to distort it slightly, and of course you could display story elements out of sequence, and it still in theory should be a good story. So
yeah, I think you were using heuristics at that point. Yeah. So you were actually saying
by
defining what is genre typical.
Yeah, but that was the trick to formalise it, was to go with Chris Folger's model and then understand each phase is really just an interaction between two characters wearing archetypal masks, and use the Jungian archetypes.
Yeah.
Which add a lecture of formality.
Mm-hmm. Yeah, this adds formality, and this is exactly what we are as engineers are looking for, namely these kind of precise definitions.
And the other thing is quite interesting what they're saying about making things explicit, and a lot of people saying the heuristics and stuff are quite implicit in a lot of ways. And I think what's quite interesting for me in a good story, a lot of it is what is not said, that you can read into it in a way that's not made explicit or not articulated. And I wonder how one would cope with that from an AI perspective.
Yeah, the way one reads, somehow trying to make things explicit. To make that explicit. Well, there apparently is some research on how readers react to texts.
Well, it was how you search for the stuff that is unsaid in a story, the stuff that actually gives it its multi-layered dimension, and often its emotional content is the bit that isn't said.
Well, it's just another search problem, but in this case you have a model of response, and you search things out as well to see what the sort of ramifications are of the things that you're finding. It just makes the problem worse, that's all.
That's what I thought.
But there's a difference between explicit search and implicit search. Yeah. So explicit search means you have to construct the whole thing and look through it. And implicit search says you have a mechanism for generating examples in your search space, and then you evaluate each one to see whether it's one that you're interested in.
Right.
So an implicit search, you can have a model which spits things out which are in your search space, okay, and you can make your model arbitrarily complex, so you can do what we would call theory of mind, which is a very simplified version of psychology, in which you're predicting what inferences or reactions people might have in this situation. And that's a more complex way of doing a similar sort of thing, where instead of actually building the tree and looking at the heuristic, you're spitting stuff out from this enormous space.
So, but you're spitting them out in order.
Probably you're spitting them out in some order.
In some order, which is then actually building in the same way that, for example, these kind of what you call explicit search would also spits them out. Breadth first search spits them out also.
But it's a bit more complicated than breadth first search.
Certainly, but the more
because otherwise it
complicated
gets too big.
But the more complicated thing about it is that you're using heuristics in order to create this order.
Yeah, absolutely.
And,
but the heuristics
so
are,
the complexities in the heuristics.
but the heuristic is actually a model. So the heuristic isn't if this then go that way, which would be a very simple heuristic. The heuristic is saying something like run this model, and then the answer is your heuristic for deciding what to do next. So heuristics can be a lot more complex than you think.
Yeah.
But then, I mean, actually you need a whole cultural model. Because if, for example, these things happen, if something is expected and then it doesn't occur, then this is the fun of it. But then you need to know what would be expected in a certain cultural situation.
Oh yes, we've been doing this. So that's what we've just been doing.
There's often that which you don't just need to generate a story, you need to present it somehow, which means generating good flowing prose.
Well, if you're writing prose, yes.
Or what? Well, if you want to generate an actual film from the computer as well, you can. That's even harder. But you need some way of delivering the story once you've generated it.
Yeah, but you may be generating it and delivering it as you go along, okay, rather than generating it first and then delivering it.
Okay. So, for me, something that is artificially intelligent is something that exhibits behaviours that appear to be intelligent. And that's a definition that comes from virtual humans, but also from animation, etc. Now there's quite a few techniques within that I think you'll be struggling to put to search. So for example, one is that where you put together a lot of simple concurrent behaviours, that gives the appearance of intelligence. So that's used a lot by animators, a lot by creators of virtual humans. Emergent behaviour, flocking behaviour, particle behaviour, again can give the appearance of being intelligent, but also there's a lot of work in social interactions, things like mirroring responses from a human. If you move forward, I move forward, but not by quite the same amount. The amount of time I put my gaze to your gaze. There's a lot of work in virtual human research that certainly people report that they believe it's intelligent, they respond as if it's intelligent, so it by all means appears intelligent.
Yeah. I mean, and algorithms are called local search algorithms. So you can actually, the idea of having something emerging, having something is just a distributed form of search, but you're still performing search as a whole population. So it's not anymore a single unit, a single CPU doing the search, but you now distribute the
So
search.
for example, the eye gaze example that I've just given you, that doesn't use any search at all. It simply uses a mathematical equation or connecting the eye gaze of the human to the eye gaze of the virtual human, and it's using basic observation of what is done in the real world, putting it to a mathematical equation and putting it here. So that
I think I think what we have to distinguish here is searching the whole search tree versus traversing a single node, a single edge from one node to another node. I think the example that you just gave is actually the traversal of one node to another node, like the decision, the individual decision about the gaze and where to focus on. And this in itself is now, I would see as an edge in the search tree that then creates the whole search tree, and then in the end creates the product of the two virtual characters interacting with each other. So each operator of moving from one node to another node via an edge isn't search. That can be just a simple procedure that can be very reactive. I'm in this state. If I'm in this state, then I'm going to do this following thing. But what we have now is, because we have now several entities performing these transitions from one node to the other via an edge, you have now a distributed search of the search tree. So I would say it's therefore still search. Margaret. I know whether you
Votes?
May I ask something to answer?
Yeah, sure.
Does search have to do with planning in the sense that there is a goal? Because otherwise I'm not searching for
Yeah,
something.
you need to know where you
And
want.
the mathematical equation, maybe it's just a reaction without a goal. I mean, I'm not an AI person.
But implicitly, but because of that, you're defining a goal. Because you're saying in which direction the search should go. You're already by defining where you want
Yes, but
the
it's only a
heuristic.
single goal.
It's a
Right.
reaction.
Yeah.
It's not a goal.
It's not explicitly.
We're running a bit off time, so maybe I should sort of like bring this to a conclusion. We to ask you a very, very quick question. You were saying that you want to, you want to do the right thing for the drama, for the story, but you also want to do the right thing for the user, for the person who's experiencing the interactive storytelling. So does this mean that you need to have some sort of dual layer of searches going into your system at
You
any
need
time?
to know what the user is after and what you are after.
So, yeah.
And so you need to know both. And that was the idea of having both utility payoff functions, to know both of them in order to be able to decide on the path.
So we need something from the author, we need something from the user.
Yeah.
There you go, great. So you can all have mince pies.
Thank you very much.